So today's video is about the distributive property. So what is the distributive property? So you have to start by thinking about the word distribute. And to distribute means that you're going to give something out to something else. You're going to actually pass it out to something. So basically it's when you distribute the number outside the parentheses with everything inside, and you're going to use multiplication. So it's when you multiply each term inside the parentheses with the term outside of the parentheses. So let's look at a real world application. So I'm sure most of you have been to Bojangles, and one of the things that they offer is called the 8-piece tailgate special, and it comes with 8 pieces of chicken, it comes with 4 biscuits, it comes with 2 sides, and it also comes with a half gallon of tea. So let's say you're having a big party and you decided that you're going to order 3 tailgate specials. So the question is, what would you expect to get in your bag if you ordered 3 tailgate specials? Well, you would expect that you would multiply everything that's in one tailgate special by 3. So you'd have the 8 pieces of chicken, but because you ordered 3, you'd multiply that by 3, and you should get 24 pieces of chicken. Then 1 half gallon of iced tea, but then you ordered 3 of them, so you should have 3 half gallons. And then you have fries and dirty rice, and then you should end up with 3 of each of these, and so you should basically have 6 total sides. And then you have 4 biscuits in just one, so if you order 3, you should have 12 biscuits. So basically you took every item in the tailgate special and multiplied it by 3. So we took the 3 and we distributed it to everything in the tailgate special. Well, that would be the distributive property. So now we're going to do some modeling with the distributive property. And multiplication we know is repeated addition. Therefore, if you were going to model 3 times 5, you would simply use repeated addition. So basically 3 times 5 means that you are actually adding 5 3 times, and it would give you 15. So let's think about that same logic with the distributive property. So we're going to use what are called algebra tiles, and this long tile is going to represent our variable x, and then this little tile here, the square one, it represents our whole numbers. So we're multiplying 2 times x plus 4, which basically means that we're basically going to do x plus 4 plus x plus 4 if we look at it as repeated addition. So if I use my tiles to model this, this would be x, and then I have 1, 2, 3, 4 here, and then I'd have 1, 2, 3, 4 here, which is going to give me 2 x's plus 8 whole. So 2 times x plus 4 basically equals 2x plus 8. And because the whole numbers, they're completely different tile from the x tile, we can't put them together. But we can put the 2 x's together, and we can put the 2 4's together. Even if we were modeling 2 times 2x plus 2, again, it basically means that we're taking 2x plus 2 and we are adding it twice. So repeated addition again. So if I again use my tiles to show that, I have my 2 x's now plus 2 of my whole numbers. And then if I did that again, so I have 2 more x's. And again, I add that with my 2 whole numbers. And again, if I were to total all of this up, I can put the x's together, which gives me 4 x's. And then I can put the I can put all 4 of these yellow tiles together, my 1's, and I would end up with 4x plus 4. So if I saw another example, now I have 3 outside the parentheses and 1 plus 3x. Again, it's showing me that I am basically taking 1 plus 3x and I'm adding it 3 times if I show it as repeated addition. So I can take my 3 x's for each one of these. So I have 3 x's plus 1. And then if I just do my copy, and so we see that again, and then if I copy it again, we see it another time. So all together I've got 3 x's here, 3 x's here, 3 x's here, which means I have 9 x's, and then I have 1, 2, 3 wholes, so I have 3 plus 9x. So again, the distributive property, you can basically look at it as repeated addition. The number outside the parentheses is telling you how many times to multiply what's inside the parentheses. So now let's look at how you would mainly use the distributive property without using models or anything like that. So basically you're going to take the number outside the parentheses and you've got to multiply it with everything inside of the parentheses. And a common mistake students make is they'll multiply it with the first number or first term and forget to multiply it with the second term. So please don't make that common mistake. You got to multiply the number outside with everything inside. Think about the tailgate special at Bojangles. If you get 3 tailgate specials, you got to multiply every single item in that tailgate special by 3. So first, I'm going to multiply 6 times x, and that's actually going to give me 6 times x. And then I'm going to multiply 6 times 4, and that gives me 6 times 4. Then I multiply 6 times x, and we don't know what x is yet, so that's just going to remain 6x. And then I multiply 6 times 4, and that's going to give me 24. So then my final answer becomes 6x plus 24. Even if the whole number is on the right side of the parentheses, meaning it's behind the parentheses instead of in front of, you're still going to use the distributive property because this still shows that I'm taking what's in the parentheses and multiplying it by 11. So I'm still going to use the same process. I'm going to multiply the 11 with everything inside the parentheses. So I'm going to do 11 times 9, and then I'm going to do 11 times 5y, which gives me 5y times 11 plus 9 times 11. Well, 5y times 11 will be the first thing I multiply, and 11 times 5 gives me 55, so that's actually going to be 55y, and then 9 times 11 gives me 99. And again, this is as far as I can go because I don't know what y is. And then even if you have subtraction inside, because I know all the other examples we've done have had addition, even if there's subtraction inside of the parentheses, you're still going to use the distributive property. So I'm still going to multiply 7 times 4a, and then I'm going to multiply 7 times 6b, and that will give me 7 times 4a, but then now it's going to be minus 7 times 6b. So then I have 7 times 4a first, and 7 times 6b second, and then instead of having addition, it will be 28a minus 42b. So I'll do 7 times 4, which is 28, and since it's 4a, that means I have 28 a's, and then 7 times 6b, and since it's 6 b's, then it would be 42 b's. And look, I just kept the subtraction symbol since it was subtraction. You can use the greatest common factor to create an equivalent expression. So basically now what we want to do is we want to take an expression and we want to basically go backwards. We want to figure out what did the expression look like before we got our final answer if we were using the distributive property. So the first thing you've got to do is you've got to find the greatest common factor of both terms. And we learned that in several chapters ago, how to find the greatest common factor, which basically means that we're going to do our factor tree, then we're going to pull out of our factor tree our Venn diagram, and then from there we'll find our greatest common factor. And we noticed that both 45 and 18 had 2 3's in common, which means the greatest common factor is 9. So now we know that 9 is common with 45 and 18. So that's actually going to be the term that's going to be outside of my parentheses, and I'm actually going to take both of the terms and divide it by 9. So if I do 45 divided by 9, that gives me 5, and because it's 45d, I'll have 5d. And then because I can divide 18 by 9, and that gives me 2. And like I said, your greatest common factor is going to be the number outside of the parentheses. So these are equivalent expressions because if you actually were to go through here and solve this, you can actually multiply 9 times 5d and it gives you what? 45d. And then you've multiplied 9 times 2 and it gives you 18. So they're still the same expression. We just basically went backwards to see what it looked like before we actually got our answer and used the distributive property. Like I said, these are equivalent expressions. They are equal to each other. So more practice finding equivalent expressions. So I have 24a plus 36b. I need to find their greatest common factor, which is actually 12. And once I know what the greatest common factor is, I divide both of the terms by the greatest common factor and then put the greatest common factor outside the parentheses. So this is actually going to give me 12 times 2a plus 3b. Then my next one, I have 56 and 72. Their greatest common factor is 8. Remember, the greatest common factor goes outside the parentheses, and then you divide both of the terms by the greatest common factors, and that would give me 8 times 7 plus 9x. So sometimes a question that you might see is asking if two expressions are equivalent. So basically what you need to do is you would need to simplify both, make sure that both sides are in simplest form, before you can compare them. So if I actually go through here and do 5 times 3w and then do 5 times 8, I want to know, is that going to give me 15w plus 8? Well, 5 times 3w is going to give me 15w, and then 5 times 8 is actually going to give me 40. So these are not equivalent expressions because you got to multiply the 5 with both of the terms, and it looked like this person only multiplied the 5 with the first term, so they are not equivalent expressions. Then I have 8g plus 6h, and I want to know, is it equivalent to 4 times 4g plus 3h? Again, I need to simplify both sides, make sure both sides are simplified, and once I do that, I can see if they're actually equivalent to each other. Well, if I multiply 4 times 4g, that will give me 16g, and so from the beginning I automatically know that no, these can't be equivalent because I have 8g on one side and then 16g on the other, so they're not equivalent. And what you would know is that the greatest common factor of 8 and 6 is not going to be 4. So 4 wouldn't have been the number that would have ended up outside of the parentheses if I was going backwards from 8g and 6h. Their greatest common factor is actually 2. So if there was a 2 on the outside of the parentheses, then this would have actually been equivalent. So just keep in mind the distributive property means that you're taking the number outside of the parentheses and you're going to distribute it to everything inside of the parentheses. And on top of that, you can actually go backwards from the distributive property and actually use the greatest common factor to find what was the expression before you use the distributive property. So teach the tiger something you learned in today's video.